Hello, this is CBME1 COA Block 2C Group 2. We'll bring you the 7 quality process control tools. Let's start with process flow diagram. A flowchart is a visual representation of the sequence of steps and decisions needed to perform a process. Each step in the sequence is noted with a diagram shape. Steps are linked by connecting lines and directional arrows. This allows anyone to view the flowchart and logically follow the process from beginning to end. According to its name, it's a diagram of steps and decisions. Let me give you an example. We have two shapes here. We use rectangle for the steps and decisions. Now please look at start and end. This shape is called a stadium. We use stadiums for the start and endings. Lastly, the arrows indicate the direction of steps. Process flow diagram could be as simple as this, or as complex as this. This looks intimidating, but I can tell you that this helps to focus on the processes needed for the desired outcome. Now, let's move to this diagram. It's called cause and effect diagram. A cause and effect diagram is a visual tool used to organize possible causes for specific effects by displaying them and suggesting causal relationships among theories. A popular type is also referred to as fishbone or Ishikawa diagram. In making a cause and effect diagram, you have to assume relationships, causal relationships, okay? Not romantic, but causal. Let's use this diagram. The big circle contains the effect or problem. You know what's worse than missing a person? Missing a deadline, because you'd be dead after that. Anyway, we have a line that stretches from left to the problem. This is called a spine. Next, we have diagonal lines from factors that are involved in the problem. We have lines branching out from the diagonal lines. These are the causes of the problem in their specific factors. If you think that broken coffee machines can cause missed deadlines, then assume the relationships. Write it down. Thank you. For our next tool, we have check sheet. A check sheet is a structured, prepared form for collecting and analyzing data. This is a generic data collection and analysis tool that can be adapted for a wide variety of purposes and is considered one of the 7 basic quality tools. Have you tried making a checklist of things you should bring before you leave? Check sheet is quite similar to a checklist. Just sit back and relax because you'll understand it later. And remember, please don't sleep. Thank you. Next slide. When can we use a check sheet? When collecting data on the frequency or patterns of events, problems, defects, defect location, defect causes, or similar issues. When collecting data from a production process. Check sheet procedure. Decide what event or problem will be observed. Develop operational definitions. Decide when data will be collected and for how long. Design the form. Set it up so that data can be recorded simply by making check marks or X's or similar symbols so that the data do not have to be recopied for analysis. I know, it's a check sheet. It doesn't make sense if I put a mark other than a check, but it really doesn't matter. Just put any kind of label to indicate that that certain event occurred. Label all spaces on the form. Test the check sheet for a short trial period to be sure it collects the appropriate data and is easy to use. Each time the targeted event or problem occurs, record data on the check sheet. So to sum it all up, it's similar to a checklist, but it's not list. It's a sheet. It's a check sheet, okay? And if the event occurred, just put any label to indicate that that event occurred, okay? Then voila, check sheet.
Okay, so histogram. A histogram is a kind of bar chart showing a distribution of variables or causes of problems. A histogram represents cause of a problem as a column and frequency of each cause of problem as the height of the column. So, what is the importance of histogram? A histogram is a popular tool to analyze a large amount of data. After analysis, it forms a bar chart to show influential factors in causes problems. What is the usage of histogram? In using control quality, we identify causes of poor performance, help in improving processes and the works product. In this way, causes of poor performance analysis make histogram a powerful tool to take corrective actions. While in plant quality management, a histogram serves as a preventive approach to improve processes. We use historical data to identify categories of costs affecting most. So, a histogram is a bar chart, especially in TQM. It shows the frequency of a cause of a problem occurring where the height of the bar as an indicator of the most affecting reason. Let me discuss you what is the difference between the histogram and Pareto chart. A histogram is a kind of bar chart where the height of the bar shows the frequency of the event. A Pareto chart is a special histogram where data are displayed using 80 over 20 rule. Here most significant, 20% causes are visually presented in descending order of frequency. So Pareto chart will be discussed after me. In addition to that, histogram is a type of bar chart representing the frequency distribution of the data from a process. Only one parameter can be used for constructing this chart. Let me discuss you how to make a histogram. First, you have to have the data collection. Second, you compute the range. Third, determine the numbers of intervals. Fourth, determine the interval width. 5. Summarize the record from the data collection collected. 6. Construct the graph. 7. Analyze the pattern of the graph. These are some benefits of histogram. It summarizes large data set graphically. It confirms measurements to specification. Excellent problem forecasting tool in the process, and it assists to decision making in ongoing process, most especially for our QM.
Next is the Pareto chart, which is a graph that indicates the frequency of defects as well as their cumulative impact. This Pareto chart is useful to find the defects to prioritize in order to observe the greatest overall improvement. In order to expand in this definition, let us take a look on the components of Pareto chart. First is, a Pareto chart is a combination of a bar graph and a line graph. In this illustration, we can notice that there is the presence of both bars and a line, which represents a component of Pareto chart. Second component is, each bar usually represents a type of defect or problem. The height of the bar represents any important unit of measure, often the frequency of occurrence or cause. Third is, the bars are presented in descending order. This is the required presentation in presenting the Pareto chart, which is from tallest to shortest. Fourth component is, the line represents the cumulative percentage of defects. In any Pareto chart, for as long as the cumulative percentage line is steep, the types of defects have significant cumulative effect. Therefore, it is worth finding the cause of these types of defects and solving them. When the cumulative percentage line starts to flatten, the types of defect do not deserve as much attention since solving them will not influence the outcome as much. Fifth is, a Pareto chart is a quality tool. It helps analyze and prioritize issue resolution. One is, the first bars are always the tallest, and they indicate the most common sources of defects. Two is, The cumulative percentage line indicates which defects to prioritize to get the most overall improvement. Last component of Pareto chart is, Pareto charts can be analyzed with the Pareto principle, also known as the 80-20 rule. Pareto principle came from Vilfredo Pareto, which is an Italian economist and mathematician, that states that 80% of the results are determined by 20% of the causes, which roughly speaking, 20% of the people own 80% of the wealth, or in quality terms, 80% of the losses come from the 20% of the causes. Pareto chart procedure. First is, decide what categories you will use to group items. Second, decide what measurement is appropriate. Common measurements are frequency, quantity, cost, and time. Third is, decide what period of time the Pareto chart will cover. Whether one work cycle, one full day, a week, a month, or what. Fourth is, collect the data, recording the category time or assemble the data that already exist. Fifth is, subtotal the measurements for each category. Sixth procedure, determine the appropriate scale for the measurements of the data you have collected. The maximum value will be the largest subtotal from step 5. But in here, you will consider the two optional steps 8 and 9 below. The maximum value will be the sum of all subtotals from step 5. Mark the scale on the left side of the chart. Seventh is, construct and label bars for each category. Place the tallest at the far left and the next tallest to its right, and so on. If there are many categories with small measurements, they can be grouped as other. Step number 8 and 9 are optional but are useful for analysis and communication. Step 8 is, calculate the percentage for each category. The subtotal for that category divided by the total for all categories must be drawn a right vertical axis and label it with percentages. But be sure the two scales match. For example, the left measurement that corresponds to 1/2 should be exactly opposite 50% on the right scale. Last is step 9, calculate and draw cumulative sums. This can be done by adding the subtotals for the first and second categories and place a dot above the second bar indicating that sum. To that sum, add that subtotal for the third category and place a dot above the third bar for that new sum. Continue the process for all bars. Connect the dots starting at the top of the first bar. The last dot should reach 100% on the right scale. The importance of Pareto chart is it helps a person identify the most frequent defects, complaints, or any other factor that can count and categorize.
The next quality process control tool is what we call scatter diagram. So what is a scatter diagram? A scatter diagram is a graphical representation that shows the relationship between the variables. So it says here that scatter diagram is plotting the value of x and y to a Cartesian plane to see the relationship between the two variables. As we can see on the example, it shows the plotted values of the variables, accidents, and working hours that shows a relationship. Next. Scatter diagrams are used in the quality management process of the project. It is used in the quality management process because through this diagram we can see the cause and an effect of one variable to the other. Next, scatter diagram can be used to determine the indicator variable of the project. It says here that it is the indicator of variables because it shows if the relationship is positive, negative, or no relationship at all. Next, scatter diagrams are useful to determine the relationship between two variables. This relationship can be between two causes or cause and an effect and others. It can be positive, negative, or no relationship at all. The first variable is independent and the second variable depends on the first. So, if it is negative relationship, the more the points plotted are scattered over the graph, the lesser is the degree of correlation between the variables. And if we can say that it is positive relationship, the more the point plotted are closer to the line, the higher is the degree of correlation. So, when can we use scatter diagram? First, when you have paired numerical data. Second, when your dependent variable may have multiple values for each values of your independent variable. Last is when you're trying to determine whether that two variables are related to each other.
Let's move on to stratification. Stratification is defined as the act of sorting data, people, and objects into distinct groups or layers. So you can see here two different charts. The first one is the run chart. Ito yung customer complaints. Dito makikita mo yung number of complainants from different months. So January may apat, then hanggang dun sa September may tatlo. The next one is the flow chart. Alam naman na natin lahat to. Ito yung sequence. Like sa first, ito yung order receipt. Next, credit check hanggang sa billing. Okay, next. Stratification, it is a technique used in combination with other data analysis tools. This data collection and analysis technique separates data so that the patterns can be seen and is considered one of the 7 basic quality tools. So yung kanina nga makikita natin sa run chart na yun, magkakahiwalay na yung number of complainants per month para mas maintindihan natin na mas madali natin makita. Like sa January may apat, sa February may tatlo, ganun. Next. When to use stratification? Before collecting data. When the data come from several sources or conditions such as shifts, days of the week, suppliers, or population groups. When data analysis may require separating different sources or conditions. May clarification ko lang pala sa run chart and flow chart kanina. Hindi sila under sa stratification. Yung stratification kasi is also known as flow chart or run chart. Okay.
So, control charts are also known as Shewhart charts after Walter A. Shewhart, or process behavior charts, and a statistical process control tool used to determine if a manufacturing or a business process is in a state of control. The control chart is a graph used to study how a process changes over time, and the data are being plotted in time order. In control chart, it always has a central line for the average, and that represents the mean value for the in-control process. There are two other horizontal lines called the upper line for the upper control limit and the lower line for the lower control limit. An upper line for the upper control limit means that it is a value that indicates the highest level of quality, while the lower limit indicates that the lowest level of quality acceptable for product or services. These control limits are chosen so that almost all of the data points will fall within these limits, as long as the process remains in controls, and these lines are determined from the historical data. So how are we going to use the control data chart? We can use the control data chart by comparing the current data to these lines. After that, we can now draw conclusions about whether the process variation is consistent or is unpredictable. When we say consistent, the data process remains in control, and when we say unpredictable, the data process is now out of control or being affected by the special causes of variation. If sample statistics remain between these limits, we assume that the process is in control. In conclusion, control limits of control chart represents the process variation and help indicates when your process is out of control. This versatile data collection and analysis tool can be used by a variety of industries and is considered one of the 7 basic quality tools. Thank you.